Hi everyone, it's Sorkin. Today we have a problem when we are given a m to n grid and we need to find the path with the minimum sum from 0, 0 from this position, right? From 0, 0 to m to n, from m to n. So for example, let's see in this case, right? So what is the path sum here? It's 1 plus 3 plus 1 plus 1 plus 1. So it gives us 7, right? So this path. We can also take, how many paths we can take? We can also take this path, right? We can also take this path. We can also take this path and so on. And for example, if we are taking this path, so what's the sum here? The sum here, 1 plus 3 plus 5, 9 plus 2, 11, 12. So it's 12. We are returning the one that is minimum, right? We need to return that the minimum, the path that gives us the minimum sum. How we are going to solve this problem? The way we are going to solve it, we are going to use the dynamic programming approach. And in our case, we are going to use dynamic programming bottom-up approach. So how we are going to do that? So we are going to create a two-dimensional array with the same size as our grid, m to n. And we are going to, so what's the dynamic programming? Dynamic programming is that we are solving a sub-problems, small problems, and we are building up our solution. And along the way, we are optimizing our solutions. So let's take this example. For example, let's take this one, right? So from here, from 1, where we can go from 1, so how we can arrive here to this position, right? So we can either go to right or we can go down, right? Right or down. So in this case, how we can come to this position, to 0 and 1, right? The only way is from here. So this one is 1, this one is 1 plus 4 is, so we are just populating this cell, right? 1, 4. And how about here? We can only come from here, which means that the 4 plus 1 gives us 5, right? So how about the same here, down, right? How we can come here? The only way that we can come here is from the above. So 1 plus 1 gives us 2, and so this value is 2. So we can, the only way that we can come here to this cell is from here. So which means that the 2 plus 4 gives us 6. Right now, let's populate the rest of the cells. So how about here? So the only way that we can come to this cell, right, is from the either above or from the left, right? Either from the above or from the left, and the plus this value. So in our case, we are checking that, okay, which one is this? So we need to find the minimum, right? We need to find the sum that is the minimum. So we are adding 5 plus 2 or 5 plus 4. 5 plus 4 is 9, 5 plus 2 is 7, so we are choosing 7 here. How about here? The only way we can come here, either from here or from here, the value is 1. 1 plus 5 gives us 6, 1 plus 7 gives us 8, so we are choosing 6 here, right? So now we are going to the next cell. So to the next cell here, we can either come from here or we can come from here. So 6 plus 2 gives us 8, and 7 plus 2 gives us 9, so we are choosing minimum, we are choosing 9. And how about here? So here, we can either come from here or we can come from here. So 9 plus 1 gives us 10, and 6 plus 7 gives us, 6 plus 1 gives us 7. So we are 7, we are putting our 7, and the minimum value that we can get here, it is 7. So as you can see, and it's this path, right? So that gives us 7. So again, what we did here? What we did is, first we solved the sub-problems. First we solved the sub-problems that can be solved easily. So this one and this one, right? Because the only way we can go to the next cell is from the left, and the same here. The only way that we can go to this cell is from the above. So we solve these problems, sub-problems, and then we are building up our solution. And at the end, when we are reaching to this point, we have already solved all sub-problems, and which gives us the minimum value that we need, which we are returning here. Okay, first thing, let's create two-dimensional array, dynamic programming, where we are going to store our values. But for that, let's find out our m and n. Our m is our grid length, right? And our n is, so we can take any, so we are taking grid 0 length, right? Grid our column length. Okay, now we can create our two-dimensional array. Let's just call it dp, and we are, that is the size of new int. So it's gonna be the size of our m and n. It's gonna be size of our m and n. Okay, so after that, now let's populate our first row. So for that, we are doing int I is equals to, we're starting from 1, and the I is less than our m, and we are incrementing I. So what we are doing here, we are setting the value to our dp, right? So for I, we are populating our rows. So for I, dpi and 0, right? 0. It's gonna be the value of what? It's gonna be the value of our previous sum plus our current cell sum. Previous sum plus the value of our current cell. So it's gonna be dp I minus 1, previous sum of all cells, and 0 plus the value of our grid I and 0, right? So that is, we are populating our first column. So because the only way we can go to the next cell in the column is from the left, so that's why we are populating here the first column. And then now we are populating our first row. We can keep it the same, and here it's gonna be n, right? And here we can change that to 0 I, and it's gonna be 0 here, it's gonna be 0 here, I minus 1, right? From all the sums that up to that point, I, 0, and I. Okay, so now we created a two-dimensional array where we are storing our sums. This is our first row. We have populated our first row values here, all the sum in the first row, and then we have populated our first column. So now we can go and populate whatever is the other columns, right? So for that, let's do following. So we are going, when our int I is equals to 1, right? So we are taking our m here and I plus plus. So the same way we are doing for the n. So let's make it j here, and j and the j and the j plus. So for the our value for the I and the j, right? What's that going to be? We can either take whatever the minimum of the value, either from the whatever is in the above, or whatever is in the left, right? Plus our value of the current grid. So first we are adding the value of our current grid, right? Adding the value of our current grid, which is I and the j, plus we are taking whatever is the minimum, right? So we are taking math minimum of dp I minus 1j, I minus 1j, right? I minus 1j. Or we can actually copy paste this one. dp I j minus 1. Okay, and once we exit this loop, we have all values populated. we are gonna just simply return. So our DP will have, our two-dimensional array DP will have all the values for each cell, right? Minimum value for each cell. So and for our last cell, which is m to n, we are going to return that. We are going to return DP m to n, right? M to n. Okay, let's run it. Okay, it's a two-dimensional array. And also we forgot to set here DP 0. So for 0, for the first element, right? We are just taking that from the grid. So grid 0 and 0. Okay, and also when we are gonna return that here, it's gonna be -1 and -1 m to n. And also that should be not 0 but 1. Okay, let's run it one more time. Okay, it should be n here. Right, let's run it. Great, it works as expected. Let's calculate our time and space complexity. So what's the time complexity in our case? The time complexity is we are going through each grid one more time. So then in that case, our time complexity is gonna be m multiplied by n, m multiplied by n, right? M multiplied by n. So how about the space complexity? Space complexity is determined by the size of our two-dimensional array DP. In our case, it's gonna be also m to n. It's gonna be m to n. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.